I want to take one class for queues, okay, or let's say I want to take a class for this thing, string matching algorithm, so that on Saturday and Sunday, 4th and 5th, we can start with backtracking algorithm paradigms. So 4th, 5th, 11th, 12th, and 18th. This will be discussing about the algorithm paradigms like greedy, divide and conquer, dynamic programming, okay, all these things. And on 19th, we will be discussing about queue, hashing, or some other important concepts like how to design LRU, kind of a thing. Then 25th and 26th, we will be discussing about this thing, yours graph. Okay, so this we will be discussing. And in between, I will take one more extra class to cover the to discuss the AVL tree, generic tree, like that. Okay.
Okay.
Anything you want to discuss more, or you feel like that this should be happen, this should be there, that should be there?
Uh, no, like this also looks fine to me. Like extra classes, yeah, that would be like I'm ready to have extra classes also.
See,
It
that
will
is
cover those topics fast, right?
that will be like I will be putting a message on the WhatsApp group. If anyone is having any issue with that, then they can DM me about the same. Okay, so that's how it went. So okay, let's start with the today's discussion, and then we will discuss more about the other things later. Uh, just a minute. So, uh, searching. Today we are going to talk about a very important. So it's not about a data structure. It's more about an operation which we are doing on the data structure. So searching is kind of an operation which we perform on a data structure to find out whether an element is present in a particular data set or not. Okay, whatever the data structures, whatever the data structure you have, whether it is present in it or not. Okay, so about that is about the just a minute, huh? Let me check. Good. Yeah. So we have seen various data structures like array, linked list, keys, and everywhere we are more concerned about the searching complexity only. Okay, what will be the complexity of the searching operation there? Now, today we are going to talk about the searching specifically in the array. Okay, because all the other is very straightforward that you have to traverse all the data set, complete data set, where you have to find for an element. Arrays, particularly, we are interested more in because of the interview perspective also. So, if I talk about the searching, particularly in the array, okay. So in the array, there are two type of searches present. One we call as a linear search, and the another one we call as a binary search. Okay. So what is a linear search and the binary search? Let's try to understand that part. So suppose we have given a array like this: 1, 4, 6, 2, 5, 3, 7, 9, 10, 8. Okay, this is an array you have given. And somebody asks you to then find that, let's say, x equals to 2. You have to check whether x equals to 2 is present into the array or not. So what happens in the linear searching is you go through each and every element and check whether it is equals to the target element or not. If it is equals to the target element, then what you do? You say that yes, the element is present. If it is not present, then you say if it is not present, then you say the element is not present. Okay? So simply how the loop will look, how the code will look like for the linear searches. Int linear search. And guys, I'm hoping every one of you is doing your assignment positively, because I'm not seeing very much or very lots of doubt there. So there are only two things: either all of the concepts are clear to you and you are solving all the doubts, or either nothing is clear to you and you are not solving the assignments. Okay, so I insist, please solve the assignment. It's very, very important. Okay, so suppose we have given an array and a target element, let's say int k. We have to say, let's say string, whether the element is present or not. So how we can do? We can take a for loop, int I equals to 0 I less than length y plus plus, and let's say if error of I is equals to k, then it means that we have found our target element. So what we'll do, we'll just return yes. Okay, and we also break from it. And if we have not found the element within the for loop, we will just return no. Straightforward. We are going through each and every element by checking whether the element is present or not. Okay. So is this clear? Smita Gopal Raj. Okay. So the complexity which we are seeing here is order of n, because we are going and checking for each and every element which is present there or not. Now, this can be improved. So while discussing the data structure itself, I told you about that. Sometimes we pre-process the data so that the common operations will become efficient. Same thing can be applied here. I can pre-process the data and then we can improve on the searching complexity. Okay. How we can do that is, and that comes under the second thing which is called as binaries. What happens in the binary search is you should take a sorted array. You take a sorted array, and every time for every iteration you reduce the problem set by half. So let's understand what's the second point I have written. So let's move this part to the cool. Now, so sorted array, I will tell you why we need a sorted array, but let's assume that we need a sorted array. So to apply a binary search, we always need a sorted array, and sorting an array still takes some pre-processing or some additional complexity there. Okay, so suppose we have given a sorted array. Like this: 1, 2, 3, 4, 5, 6. Let's start with 0. 0, 1, 2, 3, 4, 5, 6, and 7. This. How this works is you try to find the middle element. What do you do? You find the middle element. So middle element is among 3 and 4. Let's say, so this is even number of elements. So you can take 3 or 4, anyone as a middle element. So I'm taking 3 as the middle element. Okay. You can see that in this, if you see or observe this middle element, you will see that all the elements on the right hand side of the middle element are greater then middle element. Now all the elements which are on the left hand side are smaller than the middle element. Okay. So this complete thing we called as a search space. What we call search space means the space in which you want to search an element. Now what I will do is I will compare my target element. Suppose target element is suppose it is 6. So what I will do, I will compare 6 with my middle element. So 6 and 3. 6 is greater than 3. So it means that your target element is present in the second half. The target element is present in the second half. Okay. So it will be present in the GitHub. So what you did, your whole space, search space is reduced by half. You started with n, now you have n by 2 elements. So what happens here is, yeah, again, I will try to, so this is the iteration one. So in this, again, I will find a middle element. So again, the middle element comes as this. So I'm just writing 2 to represent that the second iteration, this middle element comes. Then what we did, we have this. So again, I will compare the 6 with the middle element and the 6 is greater than the middle element. So now again, I reduce my search space by half. Among 6 and 7, 6 is come as the middle element. And yes, now my 6 is equally equals to the target element. And yes, we have found the element. So what happening here is every time. So I started with n, then my search space become n by 2. Then my search space become n by 3. Then my search space become n by 4. Then it becomes, sorry, I made a mistake here. It becomes n by 4, n by 8, n by 16. And this is nothing but a series of log n. Okay. So it means that how many elements we are processing is a log n elements. So the complexity here is order of log n. Okay. Is the complexity. So now you can see that you have made an improvement from order of n to order of log n. But what cost? You have to do some pre-processing so that you can apply on a sorted array only. Okay. So this is how the binary search works. I hope this is clear. Anyone is having any doubt? Okay. Now guys, can you quickly try to write a code for a binary search? Can you quickly try to write a code for binary search? And it should cover all the corner cases. If the array has a single element, if the array has odd number of elements, if the array has even number of the elements, like that. It should cover each and every case. And guys, remember the whole discussion, today's discussion is depend on your code. We are keep on modifying your code. Okay, so make your code as thorough as possible. Guys, please make sure your code should run here. Okay, I'm just giving you the link. And again, I am putting a page for binary search. This is the link for binary search, and I will be putting in the chat window as well. Okay, guys, today we are going to go a bit fast. So when you are done, please let me know you are done. Okay, cool. So it seems all are done. Now let's change the problem. Hmm. Okay, let's try to solve this problem. So suppose there's an audio.
Yeah, Nishan.
So the problem statement is, suppose you have given an array, given a sorted array. Okay. You have to find the first. Okay, in the sorted array, you have the duplicates. So you have to find the position of the first occurrence of a duplicate element. Or okay, first occurrence of an element actually in a sorted array. So what happens is here, for example, no. So for example, this is the input 1, 2, 3, triple 4. So if the input is 4, if you see the 4 is occurring, the first occurrence of the 4 is at index 3. This is the index. Okay, if you see these are the so 4 first occurrence is at third index 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. You can see that 4 is occurring at index 3, first occurrence. So it might be possible that it can be asked for 5 also. We have to give the first occurrence of 5. Okay, like that. How you can solve this problem? Think. And guys, whenever you write a code, please debug it that it is working for all the cases. It might be possible that all are duplicates like 1, 1, 1, 1, 1. It might be possible that all are uniques like 1, 2, 3, 4, 5, 6, 7, 8. It might be possible that it's a single element. It might be possible that they have 2 elements like that. Okay. Now think how you can solve this problem. And again, one tip is whenever somebody says that you have given a sorted array, always the expected complexity is order of log n. Whenever somebody says that it is a sorted array, just take a hint that it is always going to be order of log n. You have to solve it in log n. Means you have to find a condition based on which you can divide the input into half. Cool. Is the problem statement clear to all of you? Asmita, Gopal?
Yes, Nishan.
Okay. Try to. Okay. Is it done? Uh, Smita, Raju, is it done? Smita, is it done for you as well? Cool. The thing is, I'm just briefly going to explain you what we are trying to do is. So suppose we have to find the first occurrence of an element. If we look particularly at this example only, here you can observe that the first occurrence for any element is going to be, for example, this is mid. Somehow you find that this is a mid. Okay. So earlier in the binary search, what you are saying that mid is equal to target and you are returning the mid. Here, the mid needs to be greater than mid minus 1. Here, the mid needs to be greater than mid minus 1. Okay, A of mid minus 1. Like that. So where you are comparing with that, your target element should be equals to the mid and mid should be greater than the mid minus 1. Okay. Now the catch is, what happens eventually is you will be on a single element and when you try to do mid minus 1, there might be a possibility that you will go out of index. Okay, out of what we say the exception is array out of bound exception. Okay. So what could have when it can happen? Suppose the 0 comes in. So mid is 0. Then what happens? You will be trying to comparing the element which is at 0 and minus 1. So that is not possible. So what you have to do, you have to include that as well in your condition. Okay. So this is the thing. So this additional thing you need to take care of. So I have an algorithm for this. Just see whether you have thought of the same thing or you have different. This is my algorithm. So you can see that I'm trying to find the mid, and then mid is equal to 0, or the target element is greater than the mid minus 1. You can say this target element or mid element also. Both are the same. Then you have the second condition that a of mid should be equally close to the target. Then you will return the mid. Otherwise, you will go into the target element is greater than the mid. You will go into the second half. Else you will go into the first. Cool. Let's go through it once. Now, guys, is it clear what the additional condition you need? Smita, Gopal, and Raju. Smita, do you have a doubt here, or is it clear to you?
Clear, Nishan.
Cool. So let's do a variance of this problem. So right now we are finding the first occurrence. Now let's try to find the last occurrence. Okay, the problem statement remains same. Suppose you have given a sorted array, find the position of the last occurrence of the position of last occurrence of an element in the sorted array. So if 4 is given, then the output should be 0, 1, 2, 3, 4, 5. So output should be 5. Okay, this is okay. Okay, now see what change will make in the previous condition so that your this will work. Okay, so how we can solve this problem? The only thing which we need to take care of is, again, your middle element should be smaller than the next element. Okay, so mid should be less than mid plus 1. So what happens is, if that is not the case, means we have to check mid should not mid uh, could be the last element. Okay, if mid could be the last element, we will be checking. This should be mid plus 1 in this case. Okay, it will be written the mid of the position. Cool. Asmita, Gopal, Raju, are you good?
Yes, Nishan.
Okay. So why we have solved this problem? Because of the another problem which says that, just a minute, number of occurrences. Yeah, this one is the problem which need to be solved. Yes, the link to the problem. This is the original problem which we are trying to solve actually. You have to find the first and the last position of the element in a sorted array. So what you will do, you can call the first occurrence function, and then you can call the last occurrence function. Okay, and it will help you out. So I will put here also first and last occurrence. Hmm, yes. If you want to go through the code, go through the problem statement, you can go. Cool. Asmita, Gopal, Raju, are you good? Awesome. Because of this problem only, we have solved the first section and the last section. Another problem. We Here the problem statement also. Okay. This is a problem which I was talking about. So what happens in this problem is you have given an array which is increasing to a point and then start decreasing. Okay. So you have to find what is the peak element in it. At what point it is increasing and what point it is decreasing. So for the sake of the argument, we will consider that only it is only a single peak element is present. Okay. For the time sake, we can assume that only a single element is there which is incrementing and then decrementing. Just a minute, I will put it. Cool. Is the problem statement clear to you guys? Asmita, Gopal, Raju.
Output is 9, right? Here.
Yeah, sorry for that. There's a network. Okay. Okay, let's complete this. Let's not take a break or something. Let's do this. Okay. Try to solve this problem. This problem is clear. So the output for this input should be 9. Okay. Try to solve this. I will be back in a minute. I will put the link, lit code link also. So you can try there as well. In the lit code link, there is one difference is they can have multiple peaks. So any one of them they are getting as an answer. But here you can assume that you have only a single peak. Guys, is it done? No. Am I audible? Asmita, Gopal, Raju.
Yes, Nishant.
Yeah,
Gopal and Raju, is it done?
I'm handling the corner cases, Nishant.
Take your time. See, take your time. Not in a hurry. Okay. I'm not in a hurry. You can take your time. Mm. And as I told earlier also, if somebody asks you to find anything in a sorted manner, the expected complexity is always order of log n. Guys, I will be back in 5 minutes, okay?
Nishant, one question. So we
Yeah.
can have a decreasing array also, right? Like 96420 only.
Yes.
Okay, okay.
This is a complete array only. This is a single input. So this input is like increasing at a certain point and then start decreasing.
Like I was asking, like if we are getting an input which is like decreasing only.
No, it could be. It could be all increasing, it could be all decreasing.
Okay.
If it is all increasing, then the last element will be the
Hmm.
answer. If it is all
Yeah.
decreasing, then the first element will be the answer.
Yes. Yes. Okay.
Okay, I will be back in 5 minutes. Okay, just try to do this. I think you guys can do it. Okay, and then I will discuss this problem with you. Okay, is it done? Any particular problem you guys are facing? Gopal, Raju? Guys, am I audible?
Yes, Nishant.
Raju, Gopal, you want me to discuss? Okay, anyhow, I will discuss this one. So, look here carefully. So, what we have to do is, we have given this particular array, 1, 1, 3, 5, 7, 9, 6, 4, 2, and 0. Now, we have to find the peak element, means we have to find the element which is greatest of all. So 9 is greatest. If you look closely to 9, it is the only element which is greater than both the left hand side also and the right hand side also. Okay. And if you make another observation, you will see that all the elements on the right hand side follow that the 3 is smaller than 5 and 5 is smaller than 7. And the right hand side is 6 is greater than 4 and 4 is greater than 2. So what you can do is you can find out the mid element, find mid element, and then check if A of mid is greater than A of mid minus 1 and A of mid is, is greater than A of mid plus 1. It means that the mid is the answer. Okay, you can return the mid. Now you have to decide whether you have to go into the left side or the right side. So else, if A of mid is greater than A of mid minus 1 and A of mid is smaller than A of mid plus 1. So this is the condition in the first case. So it means that you have to go into the second half. Okay, go to second half. Else go to first half. Okay, is it clear? The other corner cases you have to make sure of, like mid minus 1 we are using, so it might be a possibility that mid is equals to 0. Mid plus 1 we are using, it might be a possibility that mid is equals to n minus 1, like that. Okay, like we have handled earlier. Good. Are we good? Gopal, Raju?
So Nishant, in case of like if we consider only decreasing array like 96420 only.
Mhm.
So I guess when it comes to 9, it might fail because the first
Ah,
comparison we are using mid minus 1.
that's what I told, na, that like we have done here, na, that if we are using mid minus one, we are having one more condition that if mid is equals to 0. So that check, we can have it here as well.
Okay.
Okay, the same thing we can have it here as well. Okay, just try to go through it once and then we move forward. Okay, are we good? Asmita, Gopal, Raju.
Yes, Nishant.
Cool. Now let's move to the next problem. Next problem is search in rotated array. This is also an important problem. Sorted, rotated array. Okay. So in this problem, what happens is, suppose let me so by any chance, anyone of you keep tracking of how many problems we have solved so far, including assignments in the class? By any chance, no, it's not necessary. Gopal, Raju, so that did you made any count? How many problems you have solved? Good. By the way, I also never make a count or something. Okay, let's take an example here, and I will try to explain you what does this problem means. Suppose you have given a rotated sorted array which is already rotated with certain number of times, which is already rotated certain number of times. What does that mean is, so suppose if I look at this input itself, so suppose our input was 1, 2, 4, 5, 6, and 7. This was the sorted array. Then what we did, we rotated some certain number of times. We don't know how much. So this I rotate 3 times. So it becomes 4, 5, 6, 7, 0, 1, and 2. Okay. This particular is given as the input, and this is we called as sorted rotated array. Sorted rotated array. Okay, this you called as a sorted rotated array. Now, what you have to do, you have given an element and you have to find the element in this particular rotated sorted array. Okay, you don't know how many times it is rotated. So it will be, if you try to visualize it, it looks something like this. It goes to a peak, and the remaining portion is here. Okay, something like if I create a visualization for the above one, it is something like this. Okay, it means that you have cut this much and put it in the back. Here. Here. Okay, so it will look like this. Now you have to search an element in this. Is this problem statement clear? Asmita?
Yes, Nishant. It's clear.
No. If this problem is clear, no doubts, please try to solve this. So you have given the input is this. This is the input, okay? This is the input. You have to search in this. Cool. I will be back in a minute. Guys, are you done? Asmita Gopal Raju. So guys, listen to me. Guys, I'm audible.
Yes.
So there are two ways to do it. In the first approach, what you can do, you can find the pivot element, the element which is the greatest element among all. And then you will see the target element can be in the first half or can be in the second half by comparing the first element with the pivot element, means 4 and 7. Suppose you are looking for 2. So you know that if you compare 2, whether 2 is between 4 and 7. No, it is not. So it is going to be in the second half. Then you apply the normal binary search on the second half. Similarly, if you have to find 5, so 5 lies between 4 and 7, so you can apply the binary search between 4 and 7. This is the one way to do it. Second way, second approach is without finding the pivot element. Without finding pivot element. This is the class assignment you have to do it. Okay. By using pivot element and without using pivot element. Okay. So both the approaches you have to do it. The first approach, almost I have told you about, and second approach you have to think about. This is a class assignment. Cool. So can you guys try to do it by yourself over the week? In the week. If you won't able to do it, I will discuss in the next class. But I want you guys to give it a try. Binary search looks like a very simple thing, but you have to cover a lot of corner cases. Okay.
Yes, Nishan.
Will that work, Gopal?
Okay.
Cool. I'm stopping up here today. In this week, I'm trying to plan an extra class for you guys. Okay, we can discuss the string matching algorithms in that class. So I will let you know. Okay. Thank you, guys.